Find points where the tangent line is horizontal or vertical. Our curve is given by x equals t cubed minus 3t, y is equal to t cubed minus 3t squared. Couple of things here. Tangent line is horizontal when dy dt is equal to 0. Tangent line is vertical where dx dt is equal to 0. All of this is in terms of t, but look at what we're asked for. Find points where the tangent line is horizontal or vertical. And for these points, we need to be thinking about x, y coordinates. I'd like you to go ahead, pause the video, do the work, come back when you're done. Well, how do we do? Let's find out. dx dt is 3t squared minus 3. dy dt is 3t squared minus 6t. So dx dt will equal 0 when t is equal to plus or minus 1 by factoring out 3. You set the thing equal to 0, square root. dy dt will equal 0 when t is equal to 0 or 2. Same thing, we go through, we factor some stuff. Notice we didn't need to consider dy dt over dx dt. We were just concerned with where either one of them was 0. Well, now that we have values for t, I put them into a txy table because it helps me to organize stuff. dy dt equaled 0 corresponded to t equaling 0 or 2. When t is 0, x and y are both 0. When t is 2, we have the point 2, negative 4. So the graph has a horizontal tangent line at 0, 0, and at 2, negative 4. When t is plus or minus 1, well, when t is negative 1, we have x is 2 and y is negative 4. When t is 1, we have x is negative 2, y is negative 2. And so we have, the graph has a vertical tangent line at 2, negative 4, negative 2, negative 2. You may notice something about what we've written down either in the table or in our final answer. Do you notice anything interesting? I do. We wrote down 2, negative 4 as points associated with having both a horizontal tangent line and a vertical tangent line. Now, how on earth is that possible, you ask? Let's ask GeoGebra. Here I've graphed our curve. X equals t cubed minus 3t. Y equals t cubed minus 3t squared. I swear that's what that says. And we see here at the point 2, negative 4, the graph actually crosses itself. One of these would be associated with the value of t equals negative 1, and the other would be associated with the value that t is 2. And in fact, the vertical tangent will be where t is negative 1. The horizontal tangent will be where t is 2. So with parametric equations, we can get functions that are not, we can get graphs that are not functions of x. They are parametrically defined as functions of t for the x-coordinate and the y-coordinate. And then you get interesting things that can happen, like a graph crossing itself.